Let's look in your textbook at a table in Appendix A on the 15 nearest stars. And these are the nearest stars to Earth. As you can see, the Sun is in the list. Notice the column called apparent visual magnitude. And notice that it's labeled a small m sub v. Small m means apparent visual magnitude, and visual, small v, means visual. So apparent visual magnitude is how bright the stars appear to your eyes. And notice that the numbers are not nice, usually not nice even numbers. We can see here there's a negative 1.5, and we see here there's a 12.6. So we see fractions. Let's call Cirrus A the A star, and let's call the Luyten 726-8A the B star. And let's find the magnitude difference between these two stars. So we want to solve for m sub b minus m sub a, which is called your magnitude difference. So if we look in the table of m sub b, notice we dropped the sub v because both magnitudes are given in the visual band. So we're just going to call b, m sub b for blue for the B star, and m sub a for the A star. So m sub b is 12.6, and we're going to subtract off m sub a, which is a negative 1.5. So we have 12.6, and a negative 1 times a negative 1 is a plus 1.5. We solve, it's 14.1. So the magnitude difference between the A and the B star is 14.1. Well, what about the flux ratio? How are we going to solve for the flux ratio? An equation in your textbook relates the magnitude difference to 2.5 times the log of the flux of the A divided by the flux of the B star. We already know the magnitude difference. It's 14.1, so let's add it in. Let's divide both sides of the equation by 2.5 and solve. So 14.1 divided by 2.5 is 5.64, and 2.5 divided by 2.5 is 1, so we can ignore it. And that is log times the flux of the A divided by the flux of the B star. Now we want to solve for the flux ratio, not the log of the flux ratio. So how are we going to solve for this? There are two ways we can solve. Let's look at one of them. Now you need a calculator. I'm going to use the Google calculator. Now to solve for the flux of A divided by the flux of B, and you've given 5.64 is equal to the log of flux of A over flux of B, enter into your Google calculator. First thing you're going to type or hit is the inverse key. The second thing you're going to hit is the log key. And you should see something like this in your window. You should see a 10 to the power of 5.64. You see a 10 because log is referring to base 10. So the next key you hit is the equal key. So you should see in your window now 436,515.83224. And I'm going to drop everything off the decimal point. So the flux of A divided by the flux of B is equal to 436,515. Or the A star is 436,515 times more brighter than the B star at its surface. Now let's look at another way to solve it using our calculator. Since we know log is base 10, what we can do is rewrite this equation on the left to 10 to the 5.64 power, and that should equal the flux of A divided by the flux of B. So now what you're going to do is type 10 in your window. So press on the 1 key, then the 0 key, and that'll give you 10. 10. Then find the X to the Y key, click on that, and type 5.64 in the little box, and then hit the equal key. And you'll see the same value in the window, 436,515.83224, which we drop everything off the decimal place, and we see 436,515. Now, let's take a look at the number of significant figures. So we see in this equation there's only 3 numbers there. So at best we should round this to 3 numbers. And since 515 is greater than 500, the answer we're going to say is 437,000. We're going to round 515 up to 1,000 and convert 436,000 into 437,000. So the A star is 437,000 times more brighter at its surface than the B star at its surface.